Almost everything you do online, streaming a movie, sending an email, you name it, it's all powered by a technology you've probably never even heard of. Today, we're going to pull back the curtain and meet the ancestor of the modern cloud. We throw that term, the cloud, around all the time, don't we? But what does it actually mean? To really get to the heart of it, you have to ask a different question. What was the technology that made it all possible in the first place? And that's exactly what we're going to do. We're going to dive in and explore that powerful, foundational concept that makes everything we do today work. All right, let's get right to it. First things first, what exactly is a distributed system anyway? Okay, so here's the textbook definition. It sounds kind of simple, but the idea behind it is, well, it's huge. Think of it like this. You couldn't build a skyscraper by yourself, right? But with a huge team of workers, you could. In this case, each computer is an independent worker. They're all networked together, coordinating to get that one big job done. Now, you might be thinking, wait a second, isn't that just a parallel system? And that's a great question, but there's a really crucial difference. Parallel systems are what we call tightly coupled. Imagine a bunch of chefs all working around one giant kitchen table. That table is their shared memory. A distributed system, on the other hand, is loosely coupled. Each chef has their own private kitchen station, and to coordinate, they have to send notes or messages to each other. It's a fundamental difference in how they're built. So, we know what it is. Now we get to the really exciting part. Why go through all this trouble? What's the real payoff of making all these computers work as a team? Oh, the advantages are just massive. For starters, you get way more bang for your buck. It's much cheaper to link up a bunch of normal computers than to buy one giant, super expensive machine. And together, that team gives you way more power, lets you spread the workload out, and best of all, it gives you resilience. If one computer in the network goes down, who cares? The rest of the team just keeps on working. Of course, it's not all easy. I mean, managing a big team is always more complicated than working by yourself, right? Well, with all that power comes a pretty unique set of challenges. And these are the trade-offs. Just trying to write software that can coordinate across all those machines is incredibly complex. A single hiccup in the network can bring everything to a halt. And as you can imagine, with more machines connected, security becomes a huge concern. These are serious engineering problems you have to solve. Okay, so we know the what, the why, and the why not. So let's take a quick look at the different ways you can actually design these systems. Think of them as the different blueprints for building. First up is the one you're definitely familiar with, even if you don't know the name: client-server. Every single time you open your web browser is the client. It's requesting information from a central server somewhere that's hosting a website. It's a simple, super effective model, and it basically powers most of the web you use every day. Then you have the complete opposite, peer-to-peer. Here, there's no central boss, no main server. Every computer in the network is an equal, a peer. It can both ask for stuff and provide stuff. If you've ever heard of technologies like blockchain or maybe some early file-sharing networks, that's peer-to-peer. It's a total democracy of computers. And finally, we've got multi-tiered architecture. This is for the really big, complex applications. For instance, when you log into your bank's website, your request first hits a web server. That's Tier 1. That server then has to ask a database server for your account balance. That's Tier 2. And it might even check with a security server to verify who you are. Tier 3. It's a whole chain of specialized servers all working together to get one task done. Okay, so let's bring all this full circle. We started by asking, what came before the cloud? Well, I think now we have our answer. The truth is, the cloud is a distributed system. It's just the ultimate evolution of these ideas. All those amazing advantages we talked about, that resilience, the massive computing power, spreading out the workload, that's the cloud. And it's all built on this very foundation. Let's just look at that definition one more time. A group of independent computers networked together, working toward a common goal. It's such a simple, elegant idea that has scaled up to become the engine that powers our entire digital world. So now you know the bedrock, the blueprint for our digital age. And this technology isn't just about the past. It is the foundation for everything that's coming, which really just leaves one last exciting question. What incredible things are we going to build on it next?